are following all the guideline here that we have outlined. So, which is the first one is going to be this contextual data that we said. So before then, we need to say I am going to be giving you a data set on avocado sales. It is a time series data set. Now, going back to the data, we will look at the description. Good. So now, look at the aim. The aim is to forecast the average price of avocado on time series data. It is a typical time series data problem. Now, these are the data attributes. Okay, so let's copy this in. Okay, are you with me? Are you all with me?
Yeah, we are with you, Doctor.
Great. So you can see I copied this attributes. I'm going to come to, so Google Gemini is something all of you can easily have. It's very easy. You can easily interact with. So I'm using something you're going to be familiar with. But when I'm going to talk about vibe coding hands-on section, I'm going to be using what we call GitHub Copilot, and then I'll be using another thing called Claude. So let's see. Today I'll use Google Gemini. Feel free to try ChatGPT if you want. So we are going to paste this. So I will be giving you other background information on this project, such as the aim and the dataset attributes. I want you to write a Python script for an EDA task on this data set. Okay. Let me not take you guys to that route. I want you to perform act as a data analyst, perform EDA on this data. Now, let's give him the data. Remember, we have already, we have downloaded the data, which is this one. Good. So we have given it the data, and we have given it the role it wants it should perform. So you can cut this out, take it to the last part of this. So I expected to get. So let's go back to this place. Let's look at this prompt. The data shows a weekly seasonality. So it means you are looking out to know seasonality, a gradual increasing long-term trend and monthly spikes. So I expect to get information on seasonality. Seasonality, gradual increasing long trend. Seasonality, gradual increasing term trends, sorry. And then monthly spikes at the end of each month. Monthly spikes and the possible cause. So I expect the output. I expect the outputs from the EDA to shed insights into information like long-term trend, monthly spike. Good. So let's go and then let's see what happens. So you can see it's analyzing. Are you all with me?
Yes, doctor.
Great. All right. So now you can see we now have results coming out. Good. So you can see this is a peak here in 2015 around September. We still have another peak around 2016 here. We still have another peak around 2017. All right. Average price of avocado over time by conventional versus organic. So there were two types of organic and conventional. You can see the average price over time. Average price by monthly aggregated across all years. So this is the average price aggregated all year, but we do see there is quite an increase from September and October, but it decreases in November and December. Average price of volume. So the volume increases dramatically in February, a bit in May, and start reducing. So now let's look at what it says. I have, excuse me, I have performed an EDA on the avocado to shed light on the time series characteristics such as long-term seasonality, monthly spikes, and the possible cause. So long-term trend and volatility. The overall average price of avocados shows a highly volatile cyclical trend rather than a consistently gradual increasing long-term trend. So the volatility, the market experienced a significant price hike in 2017, where the average price surged from approximately $1.2 to $1.8. The cycle after the 2017 peak, the price gradually declined back downwards to the 2015-2016 level by the beginning of 2018, indicating a multi-year cycle. Then the price comparison by type. The analysis of avocado revealed a clear and consistent pricing difference. Organic avocado are significantly more expensive than the conventional avocados across the entire time series. Parallel trend. The average prices for each conventional organic avocado follow a nearly identical trend and seasonality, meaning that the external market forces like the 2017 spike affect both types similarly. The plot shows, it revealed the information, of course, we saw it. So it peaks in September and then trough around January, February. There's high volume, but lowest volume is around September. So probably that was why the price was high in September. Monthly spike, the average price of avocado peaked sharply in September. The price generally become lowest in the winter months. That's from December, January, and February. So the possible cause is supply and demand. And then we have seen all that. Okay, so now we want to execute this first part, contextualizing the temporal structure. So we are going to copy this particular prompt. Now, oops, sorry. So we are going to say here is the daily for the last 3. So we don't need this because we're already giving it the data. So we don't need that first part of the prompt. The data shows so from the EDA you've performed, take what's the data, take what the data showed, on seasonality. Of course, we know this was months, not weekend. The increasing long term. And then at the end of each month, of course, the data didn't really tell us what is okay. The data tells us that the spikes are caused by supply and demand. Okay, so it means this spike is not going to be due to promotion, but supply and demand. Use this knowledge when forecasting for the next 30 days. So in this case, we can say let's forecast for the next 3 months. Okay. All right. So let's see what happens now. Of course, it could take time because it's crunchy, trying to analyze it, get insights and all that. Okay. But I hope you are understanding what I'm doing, right?
Yes, doctor.
All right. So the next thing we want to do, so we have finished the contextualizing. So is the future signal extractions. So again, we can copy the prompt and then we'll be able to do that. So what we are interested in here is the futures. Okay, so this one is not done, but we can, of course, we can. Oh, I don't know why I keep pasting this. Okay, so good. So paste this for me. Okay, so we have seen good. So now we have seen this is the forecast that it make for okay, let me just download this. So this is the forecast that it's making. It uses a Sarima for the next 3 months. So you can see actually it's saying in the next 3 months, it uses 95 confidence interval, which is quite nice, of course, because we could actually see if we are safe. So we are possibly going to see a bit of an increase, compared to the previous spike. And this is a 12-week forecast on the sale of avocado in the next 12 weeks. Great. So we can see it tells us what it has done, and the forecast was done based on the EDA, the local trend continuation, the end of the historical data. Early 2028 shows a downward movement following the major spike in 2017. So the model initially reflects this downward momentum. Then the seasonal rise, the EDA shows that the price bottomed out in the late winter, early spring. So it begins to steadily climb towards the annual peak in September. Then the forecast for April through June capture this exact seasonal trend. So we expect the average price to be around $1.28 to $1.35 over the 3 months. So very, very great. So we have the prediction for that. So the next thing we are interested in is future and signal extractions. Okay. So now let's modify these prompts to reflect what we want to do. So of course, like I said, we don't need the data. So we are going to talk about from from the EDA you have done. So always make sure you are referring to the LLM, because sometimes it has this forget issue that you could forget and think you are talking about a new thing. So that's why you see us, we have that reference to establish continuation of what we have already started. Compute the average monthly sale, okay? Because this is not daily. The average monthly sale, the standard deviation, identify any months, okay, where sales exceed the mean plus the standard deviation, potential outliers, and note any recurring weekly or monthly pattern. Okay, then interpret what factor may explain the high sale month or deep flag or usual anomaly. So let's see what happened. Are you all together with me?
Doctor.
Is Ene still there? Or Ene, are you with me as well?
Yes.
Justina, is she with us?
She's here, but I don't know if she can hear us.
Okay. So what we are doing, you can imagine where you can apply this kind of thing. You can look around you. Some organizations or supermarkets could have time series data that they don't know what's happening. So you can use some of this knowledge to start up something. You can meet them, tell them, oh, I can help you to make sense from your data and help you to be able to really organize your data, and you can take this kind of get their data in the right format, and then you can come and do this kind of prompts engineering sort of analysis with it. At the end of the day, you write a very well detailed report and you give them. You can even start, you don't need to even charge at first. You can just go tell them and say, look, I am a data scientist or a data analyst. I've been learning this skill for a while, but I want to start applying it. I'm interested in this kind of thing. I don't know if you have data set that I can be able to crunch it for you and at the end of the day, write a report for you. By the time you do that for 1 or 2%, you build that confidence. The next thing you do is now to start finding markets. Start going to much bigger organizations. You tell them about what you can do, and then once they give you, you get those things done for them. You build that confidence over time. You solve problems. So these are the kind of things. Don't just sit out there and complain, because one of the problem I see people complain, they talk about they don't have jobs, nobody is employing them, but you can do something. You can do something. You mustn't just sit for these things to wait for you. You have to take a bold step and start solving problems. So, from what I could see here, the detailed analysis of Avocado's sale volume provides the following statistical insight built upon the initial EDA. So the monthly sale aggregated across, say, so this is the mean monthly total volume is around 402 million 692,000 units. The standard deviation is around 71 million, of course, and the outlier is around 545 million. That's 545 million 569,347.81 units. High sale months. An outlier is defined as a month where the total sale exceeds the threshold of the mean plus the standard deviation. So let's look at the high sale months. The high sale months occurred around May 2016, where we have this 561,230,530.57 units. That May 2016 is reading an unusual anomaly, potentially flagging a major non-recurring event that significantly boosts the sale volume, such as major promotion, a shift in supply chain, or a temporary competitor failure. So this is actually the reoccurring patterns for each month. We could see how the patterns reoccur: 244 million, November 238.5 million, and so on. Interpretation of high and low volume. So the high sale volume in the first quarter, winter, early spring suggests a period of peak supply. This aligns with the EDA, which shows the prices are lowest during this high volume period. So then it tells us about the recurring pattern. So again, we have addressed this issue. I'm trying to make sure if we could beat time. Excuse me. I'm going to jump this part of because it was just a suggestion, and I put the link for the hybrid part. Of course, I'll also jump the schema because already we have it in CSV file format. So the next thing is going to be the forecasting. So the forecast, remember, we talked about the tax one, which is short-term forecast. So let's look at tax one, or tax A, sorry. So the first tax is short-term forecast. So we say short-term. And so we are looking at 3 months. And then we said forecast the expected sale. So we said you should forecast and then the second tax is tax B, which we said is long-term forecast. So in the long term, we are looking at 1 year. Let's look at a whole 1 year for the long term. And what we are expected to do is provide a baseline forecast plus 2 scenarios. So provide a baseline forecast plus 2 scenarios. And what are those scenarios? So scenario 1, normal condition. Sorry. And then scenario 2 with a planned disruption. I'm going to use disruption. And scenario 2. Such as failure of a competitor. In high peak months of so if you follow what we have been doing, you will see that the high peak months it's around September. Okay, so what happened if there is a failure of a competitor in September? Okay, now let's see what happened. In addition, provides a 95% confidence interval for both. So in addition, right? So let's see now what happened. And what other ones? So we also talk about anomaly detection, which I think we have dealt with anomaly detection. Yeah, of course, the rest are something you can handle. So I think this is a good once this gives us, we interpret the results, then we can see how to wrap up. So what I'm trying to show you is how you can put this prompt engineering into effective use. How you can be able to use it to solve complex issues. Okay. Of course, for this kind of problem, if you notice, I did ask the LLM to give me the script, okay? But what normally I would do is to get the script and run it myself, because for me, there is a way maybe I want my plots to look like. There is a way I want the results to come out sometimes. So I rather like to get the scripts, looked at them, improved upon them, rather the LLM to do everything for me. So I know, but there is someone that out there that doesn't know how to code, and maybe the person is lazy to code. So it makes sense if the person has. So good. Let's see. This is a whole year prediction and also a short term prediction. So this is scenario 1 baseline, where we see of course, this is the historical sale volume, over which is in blue. And you can see scenario 1, which is very short term, just a period of 6 months. It's somewhere here. Then this is scenario 2, which of course we know we told it to do that for 1 year. And then we talk about disruption also, remember, in the month of September. So this is the month of September where there is a disruption, because if there is a failure of a competitor, we actually saw the spike, it will go up. The sales will go up because of the other person will have to do more. And then this is actually in a 95% confident interval of what we are saying. So you can actually see so this is the short-term forecast, of course, and then this is for the long-term forecast. We can actually see quite detailed about what we should expect for the whole year. That's 2018 to 2019. So scenario 2, the baseline is going to, we expect the volume is around 307 million units with 15% disruption, of course, because of September. So the forecast should increase to around 353 million units. And then the long-term plot illustrates this historical sale volume and the scenario. So now, what I'm going to do now is I'm going to now ask it to write clean reports for this analysis for me with introduction, methods, findings, discussion, and implications. Future direction. So of course, remember, I give it a role, act as the domain expert that have gone through this analysis. Was gone through this analysis, writes with summary. Good. Very important recommendations, future direction. So let's see. So now let's say you're okay with all the analysis. So this is now an expert report on what was done. Good, good, good. Good. So you can see it gives you a well-detailed report. So you can quickly just highlight this and probably copy this, go to a Word document. You can paste this here. And so you see, you already have a nice document written. So maybe you don't like this ones, you can take them out. And then you do some typesetting formatting. For example, this is not okay because you can see these hyphens and all that. You need to deal with all these ones. Okay, you need to deal with all these ones here. Normally you can take this to maybe an Excel and then organize it there to what you want. So you can build it here like this to what you want. So let's say supply implies I. So what I think this should be the arrow of imply. All right, and probably you can just make it like this. And of course, you can bold it, and you want all of them to be similar format. You can copy this, go back here. We say we don't want that. Good. So you can see now the table is better, and probably you want it a bit big. Sorry. All right. So you see, either you maybe do it for all the table to make sure you get them because this format of table is not making sense. So you do that. You do all the formatting, the headers, stuff like that. So by the time you finish all the type settings, say you are okay with them, you want probably an Arial format. Maybe I want them 1.5. Now you will see you make sure you go through it very well when it's okay. Of course, we did talk about so yeah, let's see. So this are let's say the findings. No, we did do some EDAs. So I think you can put some of the EDAs, probably you can put them here. So you go back to the original, this is where we do the EDA. We want to copy them here. Yeah, so you can copy that. Oh, you don't need to download this. You can just copy the image. Stuff like that. Populate the images you want. Of course, make sure you do that, and all that, and then you have your results or the report, and then